Hey y'all, it's Mrs. Blasky. Next section about bonding that we're going to talk about is specifically about ionic bonding. So ionic bonding is different because it involves a transfer of electrons. One atom is going to lose electrons, another atom is going to gain electrons. Ionic bonding always occurs between an element of low ionization energy and an element of high electron affinity, or basically high ionization energy. Usually that's going to be a metal and a non-metal. Now remember, metals on the periodic table are more on the left-hand side, all the way up to that zigzaggy line near aluminum and germanium. And then non-metals are on the right-hand side of that zigzag line, things like boron, carbon, silicon, phosphorus, those guys. We're not going to worry too much about metalloids right now. They will either act as metals or non-metals. What happens when we form these ionic bonds is that there has to be a transfer of energy. Anytime we break a bond, we have to put in energy. Anytime we form a bond, we get energy released. So this helps us determine why certain things are going to bond the way that they do. If we take, for example, sodium and chlorine, when we put sodium and chlorine together to get sodium chloride, to get table salt, our energy is, a lot of that energy is released. Notice that this number is negative. That means our energy is being released out. What that helps tell us is that it is actually more stable for sodium and chlorine to come together and form sodium chloride. That bond makes those atoms more stable because it's releasing out extra energy. If it was unstable, it would need more energy put into the system to make that work out. When we are talking specifically about the energy in an ionic compound, we're talking about lattice energy. So a lattice is something that has a grid on it. Most of the ionic compounds, especially as solids, they form that nice pattern of positive and negative ions, all lined up right next to each other. So again, oh, there's the bell. The magnitude of the lattice energy. Remember, we talked about magnitude is the size of the number. So whether it's a small number or a large number, we can still be using Coulomb's law to help us explain this, because we're still talking about that attraction between two opposite charged particles, or repulsion between two similar charged particles. Lattice energy increases as the distance between the ions decreases. So the closer we can get those ions to each other, the stronger that energy is going to be. So that means if we have smaller ions, they're going to have a larger lattice energy. If we have big fat ions, they're going to have a much smaller lattice energy. Lattice energy also increases as charge on the ions increase. So if we have a +1 and -1, that's going to have a certain amount of energy, as opposed to if we have a +2 and a -2, or a +3 and a -3, the larger those charges are, the more we can increase that lattice energy. And we will do these practice problems in class, but as you can see, here's a data table sort of showing us some information about how those lattice energy changes. If we're talking about lithium fluoride, chloride, and iodide, we can see, since between those three halogens, fluoride is the smallest, it's able to get the closest to lithium, and so it has the largest lattice energy of those three compounds. Chlorine is a little bit larger, so its lattice energy is a little bit smaller. It's distancing itself a little bit farther away from that lithium. And then iodide is even larger, so its lattice energy is even smaller. And then we will look at things that have multiple charges. Magnesium is a +2 instead. Notice how much larger that lattice energy gets. Magnesium, oxygen, calcium, strontium, those guys are all +2, -2 charges. Look how much larger that lattice energy gets. And again, scandium nitride, that would be a +3 and a -3. Again, an increase in lattice energy. We've got a lot of practice problems in here that we're going to be doing in class, talking about the energy of those bonds and how those bonds form. So we'll make sure that we get to those in class. Check out Schoology to get the answer key for that if you're at home. And I'll talk to you later. Bye.